Okay, I think I'll have to back it up a little. Back it up. Hey guys, Khalid here, and today I'm going to be explaining a little about this topic I read in my book earlier about delocalized electron and benzene, and the question whether there should be a ring in the middle or there should be bonds in the benzene structure. This discussion is going to be happening over here tonight. And I'm going to be explaining which eye the structure we draw and the structure that is the real one. So first off, to begin with, I'm just going to say the ring structure is the right one. Then the QQ structure we all know in resonance, the one with the bonds between the carbon atoms, that's just used for understanding the mechanism in benzene reactions. So I'm going to be explaining those in the video. Let's get started. So I can't really explain it in terms of chemistry, the electrons and the bonds, because not everybody can understand it. So I'm going to explain it through an example. Suppose you're three friends and I come to you with three fruits, an apple, a banana, or a citrus fruit, and I say to you guys, hey, you're three, remember, three fruits. I'm going to place these three fruits on the table here. I'm going to leave. And when I leave, I close the door. You're all supposed to pick one fruit. And when I come back, you should all have one fruit in each of your hands. So I leave, I close the door. Person A picks up a banana. Person A picks up an apple. Person B picks up a banana. Person C picks up the citrus fruit. So we all have that rhyming effect over there. And when I come back, each of you have a fruit in your hand. I say to you, I'm going to leave again. And now you're supposed to have a fruit again. I leave, I close the door, I come back, and now you still have their fruits in your hand, but what you did was you've changed your fruits. Now, as person A first had the apple, now person B has the apple, person A has a banana, and C still has the citrus fruits. But my condition that was, you're all supposed to have one fruit in your hand is still confirmed. So I leave once again, close the door, you all change fruits again. I come back, and now the person C has the apple, person B has the citrus, A has a banana, and so forth. I leave, I come back, you change fruits, but the basic condition was you're all supposed to have a fruit. Doesn't matter which fruit. It doesn't matter if A has a banana or B has a banana, it doesn't matter. You all were supposed to have fruits, and now you do. Now come to think of it in terms of chemistry, in the benzene structures, there are 6 carbon atoms, and there are 6 pi electrons that we call the electrons that are delocalized. I'm going to explain that later. Delocalized means. So each carbon atom is supposed to have one electron from those 6 pi electrons. It doesn't matter which electron. It just has to have one at every instant. So there are 6 atoms, 6 electrons. So what the benzene tends to do is to shuffle them around. Shuffle those 6 electrons around, so each carbon doesn't have the electron for the whole time. It's just for every instant it has an electron. So what does it do? It takes those 6 electrons and starts to rotate them over all the 6 carbons. First, one electron goes to carbon first, then it moves to the second, and the third, and the fourth, and the fifth, sixth, and then the whole thing starts again. None of the carbon will have the electron for itself. It can't say that this electron is completely bonded to me. It belongs to me. No, it can't say that. Now we come to the term of delocalized. Obviously localized means you're put somewhere, you belong to a place, you can't leave that place. But in the case of delocalized electrons, these are basically the electrons that are not bonded to a single atom permanently. They keep on moving from one atom to the second, to the third, to the fourth. So these electrons, what they basically do is they form a ring. They circle around in the form of a chain from the first to the second, third, fourth, fifth, and sixth, and then etc., etc. They don't remain bound in a single place. But when you see in books, in the benzene structure, our books show that they're bonds. The first two carbon atoms are bonded, then the third and fourth are bonded, then the fifth and sixth are bonded. We're like, the fuck? In the previous rings, in the previous image, the book shows there's a ring, and now in this image, the book shows there's not a ring, they're bonds. So what is the true story of the benzene? Actually, if you study it in a little detail, you come to know that the ring structure is actually the real one, and the bond structure is only used for understanding. But what if you're wrong? I mean, you don't know. There could be bonds. You haven't seen the atom. So I'm gonna answer that question by saying that imagine that two carbon atoms are bonded by single covalent bonds. Those bonds would have, say, 1 Armstrong bond length. When the carbon atoms are bonded by double covalent bond, and there's a sigma bond and a pi bond, the atoms will move closer to each other because they're sharing 2 pairs of electrons. They're more attractive, the bond length will reduce. So the 2 carbon atoms that are basically connected by 2 double bonds will have a shorter bond length. So if you believe in that, you don't know, because it could be bonded, you don't see that. If you believe in that story, well, tell me this. If the first and second carbon atom are bonded by 2 covalent bonds, they should have a smaller bond length, say of 0.8 Armstrong. The second and third, they're not bonded, so they'll have a normal bond length of 1 Armstrong. The third and fourth, they're bonded, so they'll have a shorter bond length, and then so forth. So there will be three bond lengths that will be shorter than 1 Armstrong, the 0.8, and 3 will be of normal 1.8 Armstrong bond length. So when looking at the benzene structure, it's a hexagon. So if we really consider that bonding structure, we'll come to know that 3 sides of the hexagon, 3 alternating sides, should be smaller in length, and 3 sides should be longer in length. I don't think that makes a regular hexagon 3 sides longer. It wouldn't be the right. So when we did an X-ray analysis or whatever they do to find out the structure of the atom, when we did that, and the images show that benzene is actually in exact hexagonal shape. There are no longer sides, there are no shorter sides. This means that each side has an equal bond length. So how can all sides have equal bond lengths when 3 sides have double bond and 3 sides have single bond? That's not possible. It is possible only in the case of a ring forms, when a ring of delocalized pi electrons form the benzene structure, when all carbons will have a complete sigma bond, 1 covalent bond, and which you could call it a half bond, a half pi bond, consisting of 6 benzene, since 6 pi electrons of the benzene that will be rotating in the form of a ring through all the atoms. All the atoms will get an equal share of those 6 electrons. That's why they call it delocalized. They don't belong to a single carbon atom. They don't contribute towards the bond length and the bond energy of a single carbon atom. So they form a ring. So that's my answer. What you all believe, I just explained it. This is my first video, so like it if you wanna, don't like it if you wanna, but if you like it, I'll appreciate it. If you don't, if you're a hater, then guess what? I just wasted 8 minutes of your life, nigga. So thanks guys for watching. Please subscribe, please share. Ciao.